This is a great opportunity to take a moment, reflect on this incredible accomplishment and all that we've learned about the moon in the 50 years since Apollo 11, and what we hope to learn with our return to the moon. It also gives us a moment to take stock of what we've learned in the last 10 years, thanks to the data from the Lunar Reconnaissance Orbiter, a mission that's been orbiting the moon now since 2009, revealing a treasure trove of information about our nearest neighbor in space. The most important way that we've been able to continue our understanding of the moon, thanks to the Apollo 11 mission, is through the study of the samples that came back. From Apollo 11 to Apollo 17, the astronauts returned a treasure trove of rocks and rock fragments from the lunar surface. Those samples have been studied for 50 years and continue to reveal secrets about the moon and indeed the entire solar system. Now, with the combination of those sample data and the data that we're getting back from the Lunar Reconnaissance Orbiter, we have a unique and fresh view of the moon and indeed the rest of the solar system. Because we have data of almost every planet now, we can compare what we know about the moon to these other objects in the solar system. And through that lens, we have a better understanding of how planets work. And it's only with the combination of the samples that we got from Apollo and the amazing remote sensing data that we can really begin to unravel the secrets of the solar system, thanks to our understanding of the moon. I think one of the most surprising things that we've learned from the LRO mission is because we've been at the moon for 10 years, we now can look at how the moon changes over time. Prior to LRO, we used to study the moon in 1 or 2 year missions. Now with 10 years of data, we can actually identify changes to the lunar surface that have happened because of impact craters or landslides on the lunar surface. We can actually see how the moon is changing. This is the first time we've ever been able to do that with the moon. And that gives us an idea of how any object in the solar system, particularly rocky objects in the solar system, can change as a result of being in the intense environment of space. On the Earth, we're protected by our environment, by our magnetic field, but the moon lacks an appreciable atmosphere, and so it's constantly being bombarded by small objects, by meteorites. When we see the traces of these impacts caused by meteorite impact, we can actually see the extent to which craters change the surface. We've never been able to do that before at the moon, and so LRO gives us that perspective. With that idea, we can then look at the surfaces of any object in the solar system and better understand how craters have changed those surfaces. It's a really unique opportunity to study, again, not just the moon, but the rest of the solar system. Thanks to data from the Lunar Reconnaissance Orbiter, we can actually understand that the poles of the moon are a really unique environment. We know they harbor very cold temperatures. There are some areas that receive no direct sunlight. And so these environments are unique, not just in the moon, but indeed the entire solar system. With the return of samples from the South Pole, we'll understand the history, the cratering history, the ages of these surfaces, and all of this information helps us put together a more complete picture of the entire moon. Remember that with the Apollo missions to the moon, they all landed on the near side, roughly near the lunar equator. By going to the south pole of the moon, we're getting far away from the Apollo exploration zone, and that gives us a real new and fresh perspective on the moon. So with those first samples and that first exploration of the south pole of the moon, we'll really gain new insights into how the moon operates and how the moon works, but indeed how the rest of the solar system works. The exploration of the moon by the Apollo 11 crew set in motion a number of things that led to me not only wanting to pursue a career in science, but in planetary science and focusing on lunar science. I'm very fortunate that my father was an engineer who helped build the backpacks that the Apollo astronauts wore when they were on the surface of the moon. It was that experience of his being part of the Apollo program that really got me inspired to study the moon and study exploration. And later through college, I got interested in studying the geology of the moon as a way to kind of connect with the moon in a really fundamental and a scientific way. And so there's no question that the Apollo missions, and particularly the Apollo 11 mission to the moon, was not only a source of inspiration, but a real sort of guidepost in something that would lead me to a career here at NASA. The LRO mission to the moon, which has now lasted 10 years, has really been a revolution in our understanding of not just the moon, but the solar system. LRO has returned the largest volume of data of any mission NASA has sent to a planet ever. We have over 1 petabyte of data. That is a tremendous amount of information, knowledge to be gained about our nearest neighbor in space. We have a record of a planetary surface changing underneath our feet over 10 years. This is a remarkable record of how a planet fundamentally works. And with that data, we can improve our understanding of not just how the moon changes, but by extension, any object in the solar system. So when we fly by Pluto, for instance, and see large, vast, smooth plains, we know those surfaces are very young because of the knowledge gained not just from the Apollo samples that were returned 50 years ago, but also the data that comes back from LRO. I think one of the most remarkable things that we've been able to do is keep a mission that was supposed to be at the moon for 2 years, now alive for 10. And in that time, we've not only learned about the moon, but also how spacecraft operate, how to manage these large volumes of data. It's actually been a remarkable experience, and I'm so fortunate to have been a part of it. I think looking forward, one of the things that we're excited about is that LRO not only will be able to support identification of safe landing sites for future human explorers, but also future robotic explorers. In the coming years, we're going to see a number of small robotic landers going to the moon, and basically we can think of the path to the moon that these spacecraft are following has been paved by the Lunar Reconnaissance Orbiter.